It is not me. Why do you keep?
I don't know. People are weird.
I was thinking about giving you a quiz just on sequences, and I looked at last year's quiz and I thought, no, man, you guys can handle it. So, we're gonna jump into series. This is probably a few 3, 4 day kind of thing. It's a great thing to know how to do. You're not gonna use this today. So I'm just going to draw it once so that I can say that I did. This sigma notation is what we'll talk about tomorrow. So for today, we're just going to stick with the basic formula notation. So I've got 2 note cards prepped, one for today, one for tomorrow. And the reason we're going to call these partial sums is because we're not going to sum an entire infinitely long series, just FYI. Okay, so we're just going to say like, what's the sum of the first 24 terms or something like that. Did you have a question?
I don't think a lot of us are here tomorrow as well, going. A lot of us are going to be there.
They're gonna try and have us back by 7th hour.
Great. Yeah. I'm just listen, everything that I've been saying this a lot lately, trying to just keep the train rolling. I can't really modify. You understand, I'll put this on the recording in case anyone wants to hear it, that I can't rightly change my lesson plans based on attendance in this building because if I did, the school year theoretically would end on like the 5th of April, right? Do we all agree? Between FBLA, FCCLA, FFA, track, whatever else, like I just have to keep going. So when you guys join things and sign up for things, like you kind of have this unwritten contract that states that I will stay caught up in school. If I'm gone for hockey or if I'm gone for wrestling or if I'm gone for basketball or track or FFA or whatever it is, by participating in those, you agree to do the work that's required at home. That's the deal. That's the contract that you signed informally. So I'm just going to keep on keeping on. Okay. So if you're not here, check Canvas. If I teach, I'll record and post. Uh, if I ever forget to post on Canvas, which I realized that I did Friday, actually, Friday was an odd day, and as I went to make lesson plans yesterday, Sunday, I realized, hi, darn, I didn't post I had canvases ready and I never posted them. So if you ever catch me and you're like, you get on to see what I did, and you're like, liar, just send me a quick email, say, hey, I think you forgot to post on Canvas, and I'll get them up there for you. But I'm pretty solid about getting them up. So that's your job. When you're gone, stay caught up. That's the deal. All right. So as you remember, we talked about this before. A sequence is a listing of numbers, right? The moment we change the commas into plus signs, then it becomes a series. And so a series is a sum of terms, whereas a sequence is just a list of them. So let's start with this. And again, as you would expect, we have to be mindful of the difference between arithmetic and geometric. So my only mission for today is to, however long this takes, make sure you have the formulas for both arithmetic and geometric, and that by the time we part ways here today, that you are adept, skillful at finding the sum of the first n terms of a series. Okay. And so for really big like geometric series, I'm not going to ask you to find the sum of like the first 86 terms because then it just gets obnoxious, right? You have to go into that real deep scientific notation. So but arithmetic, we can get a little bigger. But clearly, would we agree that this is an arithmetic series, right? We know the difference. It's +7 every time. So we can see that it's arithmetic. And so, listen, if I asked you to find the sum of the first 4 terms, you would just do that by looking at them and adding them together, right? Same would be said if I asked you to find the sum of the first 7 terms. Like you could just keep adding 7 and then just add them together. It would honestly be quicker in a case like that than it would be to go formula mode. But where the formulaic mode becomes important is when I ask you to find something like this, like S31. So the notation has changed. We're going to use a capital S, and that, of course, stands for the sum of, and the little 31 at the bottom means the sum of the first 31 terms. And so I mean, again, if I gave this to a really dedicated 6th grader and said, okay, your task, like I'll give you Laffy Taffy I'll give you a half an hour. I want you to find the sum of the first 31 terms. Like what that means is find all 31 terms and add them together. We could do that, couldn't we?
Mhm.
That's clearly not the mathematics that we want you to be doing, right? And even 31 is relatively small. So like if I really wanted to make the point, like I will in the next example, I could say like find S sub 410 or something like that. And then you realize, yeah, I don't want to do this by hand. I don't even want to do 31 terms by hand. So clearly there's a formula for this. And so I'm going to give you two formulas today. There'll be a third formula tomorrow, but for today, we're just going to knock out the bare bones, keep it in your back pocket formula for the sum of the first n terms of an arithmetic series. And then in about 10, 15 minutes, I'll give you the formula for geometric. Deal? All right, so I'll switch colors here. I'll head over to the side, and this is your formula. You want to write this down, put it someplace prominent, okay? So the formula for the sum of the first n terms of an arithmetic series is n over 2 times 2 a sub 1s plus n minus 1 times d. And why are there square brackets there? Yeah, it's as always, using squares and rounds together is a good, healthy mathematical, it's like a courteous way to present yourself. Because rounds with rounds can get a little bit, I don't know, hard to understand, perhaps confusing. So if you don't want to use the square ones, you don't have to, but they really are just big glorified parentheses, okay? So you can see clearly in this case that we have a cast of characters, right? There are some variable values involved in this. So n is going to be the number of terms that someone's asking you to sum. Like in our problem, clearly n is 31, right? And it's the same cast of characters. So that's good news, is that doesn't change. What's a sub 1? The first term. So in this case, 4. And then what's d? The common difference. And so the cast of characters does not change, and it will not change today, tomorrow, Wednesday, Thursday, right? So we're going to keep seeing these same guys that we've seen before. So let's head over here and let's make a list. I like to make a list. You don't necessarily have to, but it's what I do. So what is a sub 1? 4. What is n? 31. And what is d?
7.
Good. I just like having that handy. Again, you don't necessarily have to. I like to. And so now we're just going to go formula mode. And so you just wrote the formula down. So here we go. For the first time ever, let's calculate what we would get if we wrote out the first 31 terms of this series and then added all the numbers together. So we're going to start by doing 31 over 2. And I frankly would just leave it all raw. I mean, you can maybe work a couple things. Like if you wanted to change that to 15.5, that's fine. Do a little work along the way as much as you're comfortable with. And then the very first thing you see is double a sub 1. What is double a sub 1? 8. We should all be comfortable with that. If a sub 1 is 4, 2 times it is 8. And then we're going to put plus a multiplication problem. What's n minus 1? 30. And again, what's d?
7.
Right. So this right now is what the math problem looks like. And again, if you wanted to do even a little bit more along the way, like if you wanted to do 30 times 7 and make it 210, there's options here, right? So at this point, we just go full calculator mode and just type it in. And it's, as always is the case, just be mindful, respectful of parentheses in the order of operations. And so if you have a calculator, grab it out and practice, because you'll be having to do this by yourself. I'll give you a moment. I'll pause this while you take a moment. So having said that, did we all get 3379?
Yeah.
No calculator issues? Good. All right, let's practice again. So, and then I only have 2 examples of arithmetic. This is pretty straightforward stuff here. So let's do 156, 147, 138, 129. And I don't know, because you'll be working in Delta Math here in a little bit. I don't remember if Delta Math will give you the first 3 terms or the first 4 terms, but 3 or 4 will be sufficient. 2 obviously is not sufficient, because if you have to if you're tasked with deciding if it's arithmetic or geometric, that's clearly not enough, right? Because if you had like 2, 4, could the next term be 6 or could the next term be 8, right? So that's why we always give you at least 3. Arithmetic, let's find S sub 418. What's one thing you could tell me right now about the answer?
Big. Small. Small.
Maybe give me something a little bit different than that.
It's going to be
It's
negative.
going to be negative for sure, because it's not going to take us long. If we keep subtracting 7, it's going to take us what, like 23 or 24 tries to get down to 0. And then everything after that is negatives. And so if we add a whole bunch more negative terms, our answer is going to be really, really negative. So I apologize that I put commas in here. I kind of meant to put pluses, but that's okay. So it is a sequence. Let's find the sum of its first 418 terms. So to make our checklist, we're going to say A sub 1 equals 156, N equals 418, and D is -9. And those are the characters you need. And then you eventually you won't need to look at the formula. It's just you use it like 3 or 4 times and it pretty much just it's stuck in your head. So I'm going to start with n over 2. You're welcome to divide that in your head as you go. Can you guys do 418 divided by 2 in your heads? Yeah, so it's going to be 209 times. Again, you don't have to. It goes fast or slow as you want. And then at the beginning, we're going to do double A sub 1. What's that going to be? 312 plus, what's n minus 1? And what's D? And that's it. And so there's your mathematics. That's what it looks like. And again, feel free to do as much of the math along the way as you'd like. If your execution on this one is correct, in other words, like if you're just hitting the right buttons on your calculator, you should get negative 719,169. And that's not an entirely surprising result because, again, it doesn't take us long to get to 0. By the time we get to 0, we still have just a little under 400 terms to go. And then you think about that every time you write a new term, you're adding it. So by the time you get down into these terms like -500, -600, like you just keep adding all these together, it grows pretty negative pretty quick. So do you have any questions on that side of things? That's how you find the partial sum of the first n terms of an arithmetic series. Okay, so let's flip it to the other side. Let's do geometric. Can I scroll this yet, Andy? Okay. So right out of the gate, let's just put the formula down. Let's just get it done now so I don't have to keep it up here in the way. So this is for geometric. And if you want to find the sum of the first n terms of a geometric series, you're going to do A sub 1 minus A sub 1 times r to the nth, all divided by 1 minus r. Which, I mean, I think deriving a formula like this might be appropriate for a class like this. And if anyone would ever just like to kind of geek out and sit down and actually look at where something like this comes from, I'd be all in for that. Like I can already see something about this that's pretty cool. But in the meantime, let's just approach it as what it is. It's a formula. There it is. I plug stuff in and then it gives me answers, right? So got a few more of these than the other ones. These ones tend to be a little bit trickier. So for our first series, let's do 12, 10.8, 9.72, 8.748, ... And again, to be clear, I could have stopped after the 9.72, right? You need 3 terms to decide if it's arithmetic or geometric, right? But 4. And so now I have a new cast of characters. I mean, it's not new, it's just different than the last problem. Now there's this guy named R. And most normal people cannot look at this to this, especially this to this, and good God, especially not this to this, and say what R is. But that's what we have calculators for. So what's our systematic, repeatable way to find R?
Divide the right term by the left term.
Divide any term by his predecessor. So my arrows are kind of backwards of what we should be thinking. So like if I wanted to know what R is, I would take 10.8 and I would divide it by its predecessor, 12. But if Gabe's like, no, I don't like those ones, then Gabe could do like 9.72 divided by 10.8, right? And if Irene's like, you're all crazy, she could do 8.748 divided by 9.72. And if each of us performs whatever of those divisions, there's going to be no trickeration today. So just FYI, spoiler alert, you don't have to check today if they're legit. Like they will be either arithmetic or geometric, okay? So really, you'll only have to do one. So if you pick any one of these, we should have all gotten the same thing. What is R?
0.9.
Yeah. So again, whichever of these three yellow division problems you did, we all should agree that R equals 0.9. So that means that every term is 90% of its predecessor. And there's really not much to that. I mean, that's just very repeatable. Divide any term by its predecessor, boom, you've got R. It's obviously not arithmetic, right? And you will be tasked with that. The Delta Math is going to mix them up. And you might get like 3 arithmetics and 2 geometrics and then 1 arithmetic and 2. I mean, so your job first off is right out of the gate to look and make the call. Which is it? And then you know which formula to use, right? It's not going to tell you, I don't think, unless I didn't see it. So there I've started my checklist. So R is 0.9. What's A sub 1? 12. What is N? You don't know because I didn't ask you to. So let's find S sub 18. Okay, so our N is going to be 18. Everybody got it? So we're going to find the sum of the first 18 terms of that geometric series. All right, so to begin, we're going to write what? 12 minus 12. I know that feels weird, but the second 12 is attached, like he's in something else, times what?
0.9 to the
0.9 to the power of 18.
18. Yeah.
This is not an n minus 1, it's just an n. And then the bottom is going to be what? It's this. Yeah, it's 0.1. I'm just going to write this just to make sure that nobody gets left behind here. If you have one whole and take away 0.9, you're left with 0.1, right? 100% minus 90% is 10%. You'll find yourself more often than not just doing the 1 minus R in your head as you go. Sutter, did you just have like some kind of moment?
So you're dividing by 1 minus whatever you multiply by for R,
Right.
and it just made sense why we would do that.
Good for you, man. You had a moment. You had a thing. And why do you think it makes sense to do that?
Because if you're trying to multiply by 0.9 every time, it's basically the same thing as divide by 0.1.
Copy dot flop?
Yeah.
Good perspective. Right. Yeah. This happens more and more. The more mathy you get, the more you just start looking at things. Like, I don't know if any of you noticed, but like in this purple formula up here, did anyone notice that the two terms on top have a GCF of A sub 1? Did you also notice that if you pulled out A sub 1, it would be a difference of squares 1 minus R to the nth? No. Just saying there are interesting things like this that start to happen. It's not necessarily a difference of squares, but it could be. So interesting and lovely perspective on that, Sutter. Anyways, again, let the calculator do the lifting. I am not going to be uptight about fractions. Okay, we're going to go full calculator mode. And I still like my 4 decimal places, but Delta, I think, is often going to say go to the nearest integer. But let's, for our notes, do a little bit better than that. So when I type all of this in and I hit enter, I should get, and this answer, I mean, your answers should feel sensible. I got about 101, 0.9886. Which is interesting, but I mean, you can see why that makes sense, that as the numbers continue to get smaller, the effect that they have when we add them kind of diminishes, right? I mean, by the time we get to the 18th term, we're not adding a whole lot. most of the bulk had been acquired in probably the first, I don't know, 9 or 10 terms. All right, let's do a couple more geometrics. So, and again, this I'm going to be okay. So this one I wanted to talk to you about because I'm going to give this series to you like this. But by no means am I trying to imply that you need to give me fractions back. I just want to make sure we're clear that trying to tackle these problems and leave everything in terms of fractions, it takes. So you guys took this class probably because to some extent you enjoy math, and that enjoyment honestly just kind of just gets destroyed when we start trying to tackle these as fractions. So we just know that we could, but we're going to just leave it as decimals. So let's find S sub 15 here. Sum of the first 15 terms. And so let's go through our cast of characters. What's A sub 1?
3.
What is R?
3/4.
Is not.
1.3.
And I will tell you this time, it would be a good idea to leave your R value. Here I am contradicting myself. I would leave my R value as a fraction. And not because of any other reason than honestly, it's going to be easier for us, right? 4/3 is easy to tote around. So when I'm talking about decimals, I'm talking more about like when we get our answer at the end, let's not sweat leaving it as a fraction. But leaving R in this case as a fraction will actually be nice. Okay. And then what's N?
Yeah. 15.
15. Right. So what's my work going to look like? What am I going to write first?
3.
3 minus 3 times 4/3 to the power of 15. And then all of that is going to be divided by what?
1 minus 4/3. 1/3.
I haven't heard the right answer yet.
1 minus 4/3.
Yeah, I mean, at least Zach's on the right track. It is 1 minus R, which is 1 minus 4/3, which is negative 1/3. Got that? So again, I didn't mean to send conflicting messages. Here I am talking about decimals. There's really no benefit to turning things into decimals this early. That's just more garbage you have to tote around. So leave them pure, but at the end, embrace the idea that they're going to come out as infinitely long decimals that we're going to, choppy. If you execute this one correctly, unless I messed up earlier, I got 664.
0.4782.
0.4782. And again, if this were a delta math problem and it said round to the nearest integer, you would say 664 because that's just the nearest whole number. But we have to say integer in case they're negatives also, right? Whole numbers are just positives and 0. Any questions so far? Would you like one more practice or 2? One's good?
Yeah.
Okay, I'll skip my third one because I do feel like it's honestly going to be kind of third verse, same as the first. But this one's got a little touch.
Question.
I guess it's a little challenge, but it's not much.
Review that, Pat. I think that's.
So, and listen,
I think that's arithmetic.
technically, I think if I were being a purist about this, I wouldn't put minus signs. I would put plus negative 30 and like plus negative, but whatever. It's the same idea, right? So subtraction is just addition of a negative. You can put it either way. So let's find S sub 26. And this far in, we get it. That just means find the first 26 terms added together. In no way do we want to do this by hand. So N is 26. What is R? Say again? No, that's A sub 1. Yes. No, you're fine. No, don't be sorry. A sub 1 is definitely 180. What's R?
-6.
It is not -6.
What's 6?
No decimals yet. Okay. I should never have said the thing I said about decimals. You guys took that a little too far.
-1/6.
Thank you. It's negative 1/6. Okay. So let's take a look at where I got that from. I took this any term divided by its predecessor. I kind of like these two. Those feel pretty nice to me. I like those the best, where my green arrow is. So if I take 5 and I divide it by -30, I don't need a calculator for this. I know that a positive divided by a negative is a negative. And then I just think of division as fractions. I've been telling you this for years. Divisions that don't work, just fractions are fine. So 5/30 reduces to 1/6. So that's where that R value comes from. Good. Everybody okay?
You see that?
And now we have our cast of characters and we can get in there and do this. So what's it going to say first, Andy?
Huh?
What are we going to write first?
S of 28 equals
That's S sub 26.
S sub 26 equals 180 minus 180 times -1/6 to the power of 26.
All divided by what?
R or 1 minus R. Or no.
And it's the reason
Which is-
the reason I wanted to make sure this example got into the note card is because I want to make sure you all understand that we're doing basic math, but it doesn't always feel like that. What is 1 minus R?
It's
7/6. Because don't ever forget that doing minus on an already negative turns it into plus. Oh, good Lord. So yes, we have a 6 and a 7 in the same problem because I can't believe my eyes. Clear? Anyone having any issues with any part of that? All right, and then you're just gonna type it in. Make sure that you hit enter after the top. Enter, and then divided by parentheses. So the way it would look in your calculator would be 180 minus 180 times -1/6 to the power of 26. Make sure you hit enter right there. And then you just hit divided by, make sure you put these green parentheses. That's really important. Divided by 7/6, and then those print, without those, you'll miss it. Okay. You need the calculator to do things in a certain order. When you do that successfully, you should figure out that the sum of the first 26 terms of that series is about 154. No?
Yeah.
154.2857. Is that not what you got?
$154, yeah. Yeah. 1080 over 7.
Sorry, my answers are all over the note card, so I've tried to put them like in proximity wise, but
I can't
that-
Yeah, you just have to press enter again and it will do it.
that concludes the teaching part of this. I know that was 75% of the class, but the rest of the hour, if you go to Delta Math, you'll see that there's an assignment there, and I whatever it's called, that would be determined. Oh, it's 45 because we've been working on 44. So this will say like AMT number 45, and it'll probably say like partial sums or something like that.
Are we ever gonna have an assignment 67?
We're not going to get that far, no.
What if you gave us a bunch